Hello, everyone. Welcome to Ray's Math class. Today, I'm bringing you a real exam question from 2021, the Further Math Exam 2. So everybody knows that in the Further Math test, we separate as two. One is the exam 1 with a bunch of multiple choices. And the second one, we have the core and selective. For the core unit means it's compulsory. You have to answer all the questions. One of the core is the recursion and financial modeling. So that is very important, obviously. This question, we're gonna passing through how we deal with the number patterns, the sequence, specifically the recursion relations, and also how to use the financial solver in our cas to work it out the question. That is very, very important. First thing first, Sienna invests $420,000 in a perpetuity from which she will receive a regular monthly payment of $1,890. The perpetuity earns interest at the rate of 5.4% per annum. Determine the total amount in dollars that Sienna will receive after 1 year of monthly payment. So in this one, all right, we need to create the relations to work it out. How much money we will receive after 1 year. And every month we get the payment $1,890. So we don't have to worry about the rate of interest. How many months? Multiply the income each month. That will be the 12 times $1,890, which is $22,880. Part B, write down the value of the perpetuity after Sienna has received 1 year of the monthly payment. Look, the definition of the perpetuity here is the initial value, which is the principal. So no matter how long we receive or we keep this investment, the initial value or the principal is steady, not changed. So that is still $420,000. Now, let Sn be the value of Sienna's perpetuity after n months. And we need to complete the recurrence relations. Look, recursion relations requires two parts: the initial value, the when n equal to 0, and the relation between the consecutive or successive terms. How much money at the beginning? That is $420,000. And then for each month, all right, we would have compound ones. And then that rate would be the 1 plus 5.4 divided by 12 and then divided by 100. This is the rate, all right? This is the rate. So that would be the 1.0045 times the Sn. And then we minus the $1,890. When would it finish? When Sn plus 1 equal to 0. That is the end of the term. All right. Next one. Sienna owns a coffee shop. A coffee machine purchased for $12,000 is depreciated in value using the unit cost method. The rate of depreciation is $0.05 per cup of coffee made. The recurrence relation that models the year-to-year value in dollars of the coffee machine is given below. Now, calculate the number of cups of coffee that machine produces per year. So when the machine is purchased, its worth is $12,000. And each year, it depreciates a certain amount because it produces a certain amount of cup of coffee. How many cups of coffee made would affect the depreciation values, right? Reading from the information from the recursion relations, we can see that it's actually depreciating by $1,440 per year because it's year by year, right? So how many cups of coffee made by year? Total value divided by the price for each cup of the coffee, and then it would be the 28,800 cups. The recurrence relation above could also represent the value of the cup machine depreciating at the flat rate. What annual flat rate percentage of depreciation is represented? So the actual value depreciated per year is 1,440, and we need to evaluate depending on the total value when we purchase it. That would be the 1,440 over 12,000, and we need percentage, so we multiplied 100%, and the answer would be 12% per annum. All right, 12% per annum. Complete the rule below gives the value of the cup of the coffee machine, MN in dollars, after N caps have been produced. Write your answers in the boxes provided. Now, it's pretty easy. It's a linear relation because it's a flat rate depreciation. The initial value is the purchase value, $12,000. And then we need to minus the value because due to the cup of coffee made, right? N cup of coffee, and the price is 0.05, and then we need to give a negative sign in front because it's depreciation, not increasing, okay? So over 60% of students make that mistake, forgot to put the negative sign in front. All right, next one. For the renovations to the coffee shop, Sienna took out a reducing balance loan of $570,000 with the interest calculated fortnightly. All right, when we watched out the time terms like fortnightly, monthly, half yearly, quarterly, just highlight it would help you address it. The balance of the loan in dollars after N fortnights, SN, could be modeled by the recurrence relations. The S0, 570,000, SN plus 1 equal to 1.001 SN minus the $1,193. So calculate the balance of this loan after the first fortnightly repayment is made. So after the first fortnightly repayment, that would be the S1. What is S1? That is the rate times the S0, and then minus the repayment. That would be $569,377. Easy. Second one, show that the compound interest rate for this loan is 2.6% per annum. When we meet the question type like show that, verify, or such things, the statement is true given by the question. We just need to make it up the provement. So what term is related to the annual rate? That is the values in front of the SN in our recurrence relations. And this value is actually related to every repayment period. That's not per annum. So how we actually get the rate for the repayment period? The relation is actually the rate is equal to 1 plus the annual rate divided by how many periods we compound in a year, and then over 100. Now in here, the annual rate is what we need to know. And how many times we compound a year is 26. That is why we highlighted the fortnightly at the beginning, because sometimes you just assume, all right, it may be monthly, maybe quarterly, it depending on the method you compare. Over 100, that is equal to 1.001. And finally, you can work it out and prove your R is equal to 2.6. And that is 2.6%. Please remember, the lowercase r here representing the numbers in front of the percentage sign. C part. For the loan to be fully repaid to the nearest cent, Sienna's final repayment will be a larger amount. Determine this final repayment amount. Round your answer to the nearest cent. Now, we can see that in our real life, when we apply the loan or invest the money, doesn't matter. The final, we cannot make sure that for all the repayment period, we would receive exactly amount of the money. So finally, for the final repayment, we may be a little bit short or a little bit over. So we don't have to just wait for the next period. We just make it up the extra or just the shortage. That's it. And then we need to use our financial solver to solve the problem. Now, we can use our financial solver first to work it out how many repayments in total. It's actually 650 point something, which means we actually need 651 repayment. But for the a little bit over, we're not doing again. That's why we pay a larger amount for the final repayment. So we can do 650 here. And then for the I space, we input the annual rate, 2.6. For the principal value, initially $570,000. For the payment, that is every time we paid $1,193. Look, when you apply the loan, all right, the total value is positive, and every time you pay it, you shorten the loan. So you're actually decreasing. That's why for this case, the payment is negative. And our final target is to make sure that the future value is equal to 0. All right. Okay. So finally, the future value, we need to know what is the final thing. And how many times we pay in a year? 26. How many times in a year? 26. And then you can find out that the future value finally is equal to negative 5.59-ish. So round to the nearest cent, negative 5.59. That means after 650 repayment, we still owe the loan by $5.59. So the final repayment is actually 1,193 plus the little bit over. So you don't owe the loan anymore. Finally, that is $1,198.59. Okay. So for this one, almost 80% students make the mistake. All right, make the mistake because they consider, all right, I'm already using the financial solver to work it out. So that's the final answer. No, a little bit larger amount means the normal repayment plus this extra you owning. So you don't owe the loan anymore. Okay, now last one. Sienna invests $52,431 into an annuity from which she will receive a regular monthly payment of $900 for 25 years. All right. The interest rate for this annuity is 5.1% per annum, compounding monthly. Now, VN be the balance of the annuity after a monthly repayment. V0 is initial, Vn plus 1, and Vn can be modeled by month to month, showing recursive calculations, determining the value of annuity after 2 months. So if you're looking for after 2 months, you're looking for V2. If you're looking for V2, you need to know V1, okay? You need to know V1. And we better to write down our recurrence relations first. What is the recurrence relations? V0 is 152,431. And then our ratio is depending on 1 plus the annual rate divided 12 because it's compounding monthly. Over 100, you're going to have 1.00425. You may ask why I kept so many decimals, because first, the question didn't say how many decimals to correct. Second, it's finite. You just write it, okay? So Vn plus 1 is 1.00425 Vn, and then minus 900, because Vn representing what is the annuity left. Because every month, the annuity pay Sienna by $900. Sooner or later, the annuity doesn't owe Sienna any money, okay? All right, so easily, V1 is 1.00425 times the initial value, minus 900. That is 152,178.83. And then V2 is the ratio, right, times the V1 and minus 900 again. So finally, you would have $1,051,000, $925.59 after 2 months. Okay, after 2 months. B, after 2 years, the interest rate for this annuity will fall to 4.6%. So the interest rate is dropping. And that means the annuity cannot remaining paying Sienna $900 anymore, because it's actually compound not enough. So to ensure that she will still receive the same number of $900 monthly payment, Sienna will add it an extra one-off amount into the annuity at this time. So she needs to just deposit extra money to make sure in the following 23 years with the new interest rate, she can still receive $900. Determining the value of this extra amount, Sienna will add it, round your answer to the nearest value. So you have to separate this question into 2 parts. First one, all right, first one, after 2 months, what is the future value? Like how much money still the annuity owing to Sienna? The number of the repayment, 24, because it's 2 years and compounding monthly. The interest rate annually, that is 5.1. The principal value now is the annuity owning Sienna. So the present value, the principal value is negative. And then the payment is positive. That is always opposite, positive $900. We're looking for the future value. We know PPY and CPY, both of them are 12. And then click the entering button. You can work out that the future value would be 146,073.74. And that is not enough. So we need to find out what is the principal value for the following 23 years. So the number of the repayment would be the 23 times 12. That's the total number. New interest rate, 4.6. The principal value, we do not know, right? We're looking for it. The payment still remaining $900. the future value is equal to 0 because finally the annuity not owning Sienna any dollars, any cents. That is when you stop it. All right. Hopefully after 23 years, it's equal to 0. And PPY, CPY equal to 12. And then we can work it out. This value is equal to the negative $153,112.94. Okay. And then the difference between these two numbers would be the one-off extra amount you need to, Sienna need to deposit. So 153,112.94 minus 146,073.74. And that is equal to $7,039.20. This is the final answer. So you can see it in the real exams. Although the questions separate by several parts, they're still testing the same thing about the core. So please watch out it. All right. If you like our content, if you prefer and have interest in our classes and tuitions, please contact and follow us on our social media, the Little Red Book, the WeChat public account, and Facebook, YouTube, and such on. So thank you, everyone. Hopefully my explanation and the demonstration would be helpful, and looking forward to give you the next public. Have a good day.